Today on the Perception in Action podcast, what effect does blurring your vision have on sports performance? Can blur actually be used as a training tool to help learners educate their attention to better information sources? So it's time for a call to action. Hi, this is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Before we get to today's topic, I want to tell you about a couple extra things that might interest you if you're enjoying the podcast. First, my book, How We Learn to Move, A Revolution in the Way We Coach and Practice Sports Skills, is now available in audiobook format. You can find it on Audible or Amazon. Second, if you're interested in working directly with me, I currently have openings in my monthly mentorship program. This includes monthly Zoom meetings, either one-on-one or with your staff, analysis of your practice designs, and a monthly group discussion with coaches and instructors from a range of different sports. To find out more, please go to patreon.com/perceptionaction. Now on to the show. Hi, everyone. This is Rob Gray from ASU in the Perception Action podcast, back with another article review. In this one, I want to look at the topic of blur. What effect does blurring your vision have on sports performance and the development of perceptual motor skills? And this is inspired by this recent review paper published in Frontiers by Limbali and colleagues, looking at kind of reviewing the research that has been done on blur. And to foreshadow, there's some really interesting findings here. Not only does blurring your vision not really seem to hurt your sports performance, which has a lot of implications for some of the training that's being done out there, but also it seems to actually help in some cases. Blurring the image seems to actually help with skill acquisition. So what I want to do is kind of go through some of the paper, add my kind of 2 cents here, and show you some of the research that has been done. So what is blur, right? Blur, obviously, is what we're talking about here is lower resolution, lowering the resolution of an image, lower acuity, right? Obviously, I think most people know we deal with blur all the time, right? In our vision, right? The world around us is filled with high detail, high resolution everywhere, but we only see in high resolution with high acuity right in the center of where we're looking, where we have cones and our fovea, right? That's only place where at any one point where we get high acuity vision. Everywhere else in our peripheral vision, right, is blurred, right? Because that's where the rods are processing light, and rods have, because of the way they're connected in the eye, they have less resolution, right? So we don't really notice this, of course. We don't notice this, the world is blurred, but we deal with this all the time. So we can utilize both high detail, high acuity information from our central vision and lower resolution information for our periphery. In particular, our periphery, the low resolution is good at detecting motion. We don't need high detail to detect the movement of an object. And there's various ways that we cope with this, right? We could move our eyes around a lot, right? So if we move our eyes around a lot, we're going to see in high detail everything. Another way that's been talked about in sports is one I discussed back in episode 154 is the idea of using an anchoring strategy, or what's called a pivot point strategy, where you kind of park your eyes somewhere so that you can use effectively both central and peripheral vision for controlling actions, right? So that's a kind of the main point, right? Blur in the image is not a unique thing, right? If we add it in an experiment, we deal with this all the time. So how do we create blur in a study? So what we want to talk about is some research that has been done on what effects does blur have on various aspects of sports performance. How do we create blur? There's a couple different ways. There's dioptric blur, which is essentially, we can think of this type of blur is blur due to your eyes, your visual apparatus, right? When I take my glasses off, I create this type of blur, right? Because my eyes, my lenses, my eye muscles are not accommodating properly for me to see clearly, right? Because I can't, right? That's why I need glasses. So the world is still all around me is still in high resolution. It's just I've created a situation where I can't focus on it properly, even in my central vision, right? And the way that we do this typically in an experiment is by putting lenses instead of lenses that I'm wearing right now that help me focus. What we're going to do is make ones that add blur. And they blur by essentially making you focus or accommodate to the wrong distance, right? So they cause things to be blurry, even in your that would be in all of your vision, right? So this is blur due to your visual apparatus, what's going on with your focusing. The other main type of blur is called Gaussian blur. This is where you actually blur the image itself, right? So you take an image, whether it's a video or an image, and you add kind of distortion to it. There's various technical details. We call this low pass filtering. We're filtering all the high spatial frequencies, all the high details. So you start with the letters at the top, and you get at the bottom, you just get a blurry blotches. And so we're distorting the image, right? So no matter who looked at it, what glasses they were wearing, what lenses they had in it would be blurry, right? Because we're changing what's in the outside world to make it a lower resolution. And there's kind of the authors go through some nice discussion of the differences between these two. They're not super relevant for sports. Both have been used. I think there's some, the first type of blur where you're blurring using lenses, there's some artifacts, kind of people can still pick up some details, whereas Gaussian blur totally removes, right? So in terms of experimental, Gaussian blur is a bit more precise and controlled. An important point, though, is one of the advantages of the first type of blur, the optic blur, is that you can actually equate it to different levels of acuity, right? So I'll get to this in a second. Most people know 20/20 vision. Blurring with lenses, you can actually simulate 20/10, blurring 20/40, 20/100, right? You can equate it to some people's natural problems. Gaussian blur, you really don't have a direct equivalent to acuity, right? Because it's in the image itself. Okay, so let's get into some of the research. First of all, what's the effect of blur on anticipation and decision making? So there's been a few studies that have been done using the typical temporal occlusion paradigm. So you show a person an unfolding action like a tennis serve. You occlude it at different time points, right? Early on or later, right before the ball is struck. And you ask them to make a binary two-force judgment, right? Is it going down the line or cross court? And this is a very standard paradigm. I've kind of talked about some of the limitations with it, right? You're decoupling perception and action here, obviously, because you're making a passive verbal response. But we'll kind of skip that for now. So in this study in 2009, Robin Jackson and colleagues did a study where they did the basic anticipation task and they blurred the image, right? So they had an image that was not blurred at all, where you could see the full movement of the tennis server on a video. Then they blurred it 20%. And then they blew it 40%, right? And the interesting twist they did in their study is before they tested people with blur, they, under non-blur conditions, they had them do the anticipation task. And based on their performance, they did kind of a median split into good anticipators and poor anticipators under conditions of no blur. Okay, so then they kind of tested the blur. And what they found was this interesting finding that good anticipators, when you went from 0 to 20% blur, were kind of hurt in the anticipation task. Whereas poor anticipators, people that started out worse, they were kind of less accurate at judging cross court versus down the line. They actually got slightly better, 20%, when you added blur. And then when you add more blur, both groups kind of got a little bit better again. So the idea here is that this is kind of finding that's going to come up. Adding blur seems to help particularly lesser skilled athletes pick up information from the unfolding event. And the idea here that's been proposed, and we'll get into this in more detail, is what it's doing is getting people, when you blur the image, they're picking up more of the kinematic information, maybe because the movement, actual low-level movement cues, rather than looking at the details of the person's racket and their facial expressions and things like that. Because when you blur, you're taking those things out. So maybe by blurring, we're actually taking away distractions and getting people to pick up different information. And I'll talk about kind of theoretical views of this at the end. Okay. This sort of followed up, some other types of experiments. Ryu, who's done a lot of experiments in this, they did badminton players. Okay, they had, again, anticipating the shot direction from a video. they actually did a training intervention. So they trained people learning to do this task with blurred, okay, or not blurred or under normal vision conditions. So they either had only low spatial frequencies available, so only the coarse details, only the high details, or normal. Okay, and what they found was that the group that had the blurred video actually showed the greatest training benefits in terms of making the judgments. Okay, and to quote them, the training intervention encouraged participants to rely more on the meaningful information, which were then able to disambiguate from deceptive information in the post-test. So what they found, in this test, they had actually deceptive and non-deceptive movements in terms of the serve. And they found in particular for deceptive movements, training with the low in blur seemed to help. Okay. It also seemed to change. This was supported by, they actually changed their gaze strategy when they train. They look at different parts of the server after training with blur. That's one shown over in B here. Right. So this is again support that somehow blur seems to be helping people learn. And this is just obviously just passive anticipation of movement. Okay. So the conclusion the authors make of this review paper that summarizes the research, applying blur seems to help lesser skilled athletes because it removes distracting or irrelevant information, right? High detail information, what the person's logo on their shirt or is not needed to return a serve. Okay. And they're used more of a cognitive interpretation that it's this information may be overloading the participant. By taking it away, you're guiding them to more useful information. The question we'll come back to later on is whether there's any benefit for experts, right? If you're already good at doing anticipation and picking up the kinematic cues, does blur help, right? There's not really a ton of evidence at all showing benefits for experts yet, but I will return to that later. Okay, so these are anticipation studies. What about actually if we get to actual movement, right? So what happens when we add blur, when we're talking about skills where you're actually moving, okay? We're actually performing skills. So perception, action, perception, motor control. There's been, quite a few studies that I've actually done on this. It started with Applegate in 1992. They looked at the effect of free throw shooting on when wearing lenses that blurred from 20/20 vision. So 20/20 vision, which is 6.6 in meters, all the way up to 675, which is 2250 vision, right? So what that means is, and I've shown, if you're watching the video, you can see the image on the right is what it would look like if you had 2200 vision. So 2200 vision means, 2250 vision means what a normal person, what you could normally see from 250 feet away, you need to be 20 feet away to read with these blurring lenses on, right? So that's an enormous amount of blur, right? It's making you legally blind, right? And the image I have here shows this is what an eye chart would look like if you had 2200 vision. You can barely make out the top letter, and no way can you read anywhere the bottom ones, right? It's very, very poor vision. And what they found a non-significant drop in performance for the first blurring, but even when they went all the way up to 2250 acuity, all the way down, really, that's poor performance, there was no effect on free throw shooting performance, right? Same, Bolson et al. In 2008 looked at the golf putting, and they found the same thing. They went up to 22,000, right? So making you essentially blind. You could barely see the ball, right? And you could still putt. There was no difference in golf putting, right? This, obviously you could make out the ball from cues, but you couldn't see all the details of it, right? What I'm trying to say. So the important point about this, right, and there's more other studies like this I'll show you in a second, is there are training things out there that they're training tools and technologies that argue that improving your acuity from normal, from 20/20 to something like 2015 or even 2010, so making your acuity higher is going to help you as an athlete, right? Help you putt better, shoot better. So there's a lot of things out there trying to improve visual acuity through training and hoping it transfers to sport. This really strongly goes against that, right? If completely wrecking your acuity, making it 2200, has no effect on shooting or putting. How is making it better to 2015 going to help, right? It doesn't seem consistent at all. One thing you could argue, maybe this is the issue with this, is that the targets you're looking at, some people have argued, which is actually kind of it's kind of a silly argument if you think about it. The problem here is that the targets you're looking at are static, right? The hoop's not moving, the golf ball's not moving. Maybe there'll be an effect of blur when you actually start like hitting a ball or catching a ball where things are moving, going on. Maybe that's when you need high acuity. As I say, that really makes no sense at all, because those things rely on motion perception, which is perfectly fine in our peripheral vision, right? Where there's low acuity. You don't need high acuity to do motion perception, but people seem to think that. But in a really well studied and well done study that I cite all the time, and I've talked about on the podcast before, David Mann in 2000 and colleagues in 2007 really convincingly showed this. This is not the case, right? They did a cricket batting study where they had a cricket batter hitting off a bowling machine where there was an image of the bowler, right? And the ball came out. So they were actually hitting. They did no blur all the way up to 3 diopters. There's no easy way to directly convert diopters to acuity, but it's very, very, if you can't see the image here, it's very, very blurred, right? You can barely make out the bowler. You certainly can't see any of the detail. And what they found was that you had to go all the way up to 3 diopters, the heaviest level of blur, which is legally blind, before you saw any effect on hitting performance at all, right? So again, blur doesn't seem to really affect sports performance. Okay. And that's kind of the bottom line. Okay. The last series of studies the authors review in the paper is a really interesting series done by Ryu and colleagues, and David Mann, along with Ryu and Bruce Abernathy, looking at differences between peripheral blur versus central blur, right? So all the studies we've talked about so far have blurred everything, right? All your vision. One of the interesting things that we can do, in particular using a really clever method called gaze contingent blur, is we can selectively blur your central vision or your peripheral vision. So what we need to do is to take an eye tracker, right? And with an eye tracker, we can know where you're looking, and we can put something over that spot that either blurs it or completely blocks it out. So it's like you're looking at the world, and there's a donut of clear and something blocked in the middle. And I'm going to skip here here's an image of this. So we can just make you see the middle, or we could block the middle, or we could blur the middle or blur the surround more than it is normally, right? We could add extra blur to your peripheral vision. So Ryu and colleague did a bunch of studies where they tested this gaze. So either your central vision was blurred or blocked, or your peripheral vision was more blurred or blocked. And what they used was a basketball decision-making task. So that you watched a video and you had to decide whether to pass, drive, shoot. And they had kind of coaches. So it's coaches judge it to make the appropriate decision. And what they found is the basic finding, they compared experts and novices. Experts could handle all the conditions better than novices. Okay. The novices were more, they had trouble when central vision was blurred. Okay. When you had to use just a peripheral vision, experts could do this fine when the central vision was blocked, whereas novices really struggled. So what they did was they followed this up with a training study where they actually had novices. They had 50 novices train, and they trained under different conditions. Full vision, the peripheral was more blurred than normal, which is what I have shown in the picture here. You're clear in the center, more blurred than normal in the surround. The center blurred and the surround normal, and just a control group that just did no training. And what they found, again, consistent with those earlier findings, is that adding blur to your peripheral vision and having your central vision clear helped these novice athletes be better at decision making this basketball task. Okay. And as it says here, to quote them, the authors suggest that the enhanced learning following training in the peripheral blur condition was in part result of the peripheral blur enhancing participants' use of information available in central vision. Okay. Again, blurring the peripheral vision seems to help by taking away some information and pushing you to the other, right? Whether you think about that as a cognitive effect, where the other information is distracting, right, is the main way kind of to interpret it. Now I'll think of present my view in a second, right? So overall, the authors sum up in the paper, training with blur seems to have clear benefits for lesser skilled performers. Whether you just do it with glasses with lenses that blur out, training them to pick up the movements of an opponent or hitting off a pitch, viewing a pitcher. These seem to have clear benefits. The gaze contingent ones, where you selectively block out the periphery and central vision, seem to be even more so, have a lot of really strong benefits. And the authors proposed, and they're actually developing this themselves, they describe a bit of their system, that this could easily be implemented in VR, right? In VR, we don't need we could easily block out your central vision or peripheral vision or whatever area we want. Whether this is beneficial to experts too still needs more research, right? There's some suggestions it is, but I think it still definitely needs more research. So the final point I'll make, the way that I would interpret all these results, right, is in the constraints, right? In the constraints, ecological approach, right? Blur is a constraint, right? It's a constraint. It's taking away some information, right? It's taking away the high detail information and encouraging you to explore, right? It's encouraging you to educate your attention, in direct learning, to other information sources, right? So whether it's the kinematics of the movement, whether it's looking at more details in central vision of the players moving around, right? So I don't think we need the cognitive overload explanation, right? It's a constraint that's encouraging exploration. And one of the phrases I like to use sometimes is it's destabilizing the information attractors, right? So attractors we tend to think about in terms of movement, right? You have attractor for a particular movement pattern. There's also, I think, very clear attractors for information sources, right? We get stuck using certain information sources because they work. They pretty much work. If we destabilize that by adding a constraint, we can get people to explore different information sources in the same way we can get them to explore different movements, right? So I think all of this is very fascinating research, can easily be interpreted under an ecological constraints approach. Okay, that's it for this review of this, really interesting article. Thanks for listening, and cheers for now, and keep them coupled. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep them coupled. Gone straight away.